Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. Wait for it to pull up on the stream. What's happening? Here we go. All right. Looks like everything's in order. Everything's recording. We got good bit rate. All right, all right. Well, welcome me to another discussion from me to me about Cisco CCNA. Today is day 7. We have been doing this for 7 days. I missed Saturday and Sunday. Unfortunately, Saturday, I live right along a park. Every time I move, I try to live within walking distance of a decent-sized park for my dog. It's just easier for me. Keeps me healthier when it's that close, and I don't have to drive to it. Something that comes from that, though, is it totally understandable. I'm not mad about it or anything. That people use the park as like a festival ground sometimes. Like that's the size of the park that's next to my where I live. So there was like a little I wouldn't call it a festival. There was an event going on Saturday that lasted pretty much all day, and they had this gigantic speaker system set up that was like rattling my apartment. I didn't want that all to get caught on the recording. So I still worked on stuff Saturday as best I could in that environment. Unfortunately, I just did not stream. And then Sunday, I used for some projects I got going on the side. They're all still have to do with Cisco, still have to do with this tutorial stuff. They're just a little bit more... I'm working on the production value a little bit harder on those. I do want to put out like little 30-second in-depth blurbs about each one of these little things. So like put out like a little 30-second 1-minute thing on like the OSI model, about the TCP model, all that, just so people who have questions about this or just want a refresher, just have a real quick like like none of the BS in the beginning about like, hey, add me, subscribe, none of the like it's just going to be exactly what that is. So if it's the OSI, it's going to be exactly those 7 layers and maybe some in-depth information about each one as it pertains to networking. But I'm not going to go into like a whole... Well, we'll see. We'll see how it comes out. My hope is that it's going to be very easy for someone who just needs a refresher to just look at that and see just what they need and not a bunch of excess information, not a bunch of like unnecessary stuff that you just find yourself like trying to fast forward through and then you miss them. It's ease of use for people learning this information. And also, again, this is a way for me to explore the information in a way that I'm going to be teaching it to someone. Hopefully. So I want to make sure that information is as accurate as possible, it's up to date as possible, and it also has me exploring different ways of talking about this, because I know how I understand things, but that's not always the best way to describe things to other people, especially if they're coming to this with little or no experience like I am. So you got to balance that out, and it's going to be different for everyone, but I'm hoping that I can put something out that really resonates with people that are going through these certificate processes or just want a refresher on some of this information that maybe they haven't covered in a while. Because when you're working on networking, you learn a lot of things for these certificate processes. You learn a lot of things when you're working there for years and years and years, but you're not using all that information day to day. It depends on where you're working and what your job within that organization is. You might not touch some of this stuff for years at a time. So it's important to be able to pull up accurate information in a quick and concise manner to help you work through those issues that you haven't seen in a while. So today we're going to be talking about routing fundamentals mostly. I'm hoping that by next week I'm good enough at packet tracer that I can build up some imaginary, some networks that I build up myself that I just make up, and then I can run some trash information through them, some pings and stuff like that, so we can build up the ARP tables, we can build up the MAC address tables and things like that, and then we can go in and explore each one individually and see how a packet, how that information goes through the network, how it's transferred from router to router, how it interacts with switches and things like that. A lot of that does come with the course content I have available to me through Udemy, but I certainly don't want to use someone else's content that I paid for and put it out to the world for free, even though it's very unlikely very many people are going to be watching this. I still feel bad like releasing this person's work or these different instructors' work into the environment for free. If they had YouTube videos where they were doing that, I guess I'd feel a little bit differently, but a lot of the stuff is behind a paywall. So even though it's only like, I think I got the course on sale, so it was only like $20 or something. And that's another thing, like these Udemy courses, they offer you a lot of information, but it's, you know, it's video recordings, so you're not gonna, it's not like you're paying a couple $1,000 to take a college course or something, or a couple $100 to $1,000 to take a community college course where you have that instructor in front of you where you can come up after class, ask questions and things like that. So the problem with these videos is there are a couple of errors. There are a couple of like really confusing statements. I bring that up because I went through a lot of the routing stuff today with Neil Anderson's course, and I found a couple of points where it wasn't, like the mistakes, the very few mistakes he made were understandable. It was like flipping an IP address number or something like that, or saying 1 but typing a 0. Like that's all very understandable. But there were a couple places where it's just, it seems to be confusing for confusing's sake. It can be put together better, but it's important to keep in mind that you only paid $20 for it. So it's going to have all the information you need for the CCNA. That's why I have 2 courses. Actually, I have the Neil Anderson and I have the Bombell, because I like not only to get those different perspectives, but I also, you know, these are only $20 courses, so you're not going to get like college instructor feedback or anything like that. So you need, having another resource helps with getting around some of the more confusing aspects. And that's just, you know, everyone teaches things differently. Everyone has their own knowledge base and assumes that other people know things, or have already learned things, or you know, it's all technical. It's a steep learning curve, so we got to work with it. We got to work through it, and we're just going to show up every day, and we're just going to keep going over it. And that's honestly what got me through the day, because the first couple of times I watched one of these routing videos specifically, I wanted to quit. I was so mad. I was like, this makes no sense. What you're saying and what's on the screen do not make a connection cognitively for me. Like I didn't see how it worked, and that partly on me. You know, the more you understand about these systems, the easier it is to make these leaps. But the other part is, if you're teaching people and specifically you're teaching people that don't necessarily, you know, that are new to this information, it's upsetting when you lay it out in a way that it just makes it more confusing than it has to be. But I don't want to nitpick. As I said, $20 is a great price point for all this information. So overall, it just took me going over the video like 3, actually probably like 5 more times, to be honest. And just going through layer. Like one time I just put it on mute and I just watched the slides, and I was like, I don't want to have your voice over this, like pulling me out of my, like it was just a process. But I mean, maybe that means I learned that so much better because I was so angry and so devoted to figuring it out. So we shall see. Maybe I'll become like especially good at this routing part that I was going over. People will be like, how do you remember that? And I'll be like, man, this video I watched made me so upset. So yeah, we're going to be doing routing fundamentals today. I changed some things around with my mic. Hopefully you don't catch as much as the ambient noise around my apartment, specifically me typing on my mechanical keyboard, which is rather loud. But we're just going to work through this as best we can. So routing, we talk about routing a lot. What like at the most basic definition, what is routing? Routing is determining the best path available, and deliver the. So you're not only finding the best path, but you're also delivering traffic along said path. And the best path is very dependent on what protocol you're using. So let's just jump into that. There's a couple of different routing protocol types. And this is a little confusing for me even right now. Again, this is, new information, but there's going to be a lot of protocols within protocols. And you'll see what I mean. But to me, that in and of itself can be a little confusing. So for instance, routing protocol types, there are two major routing protocol types. There are interior gateway protocols. Again, it's a protocol. And then there are exterior gateway protocols. Neat how that works. There's an interior and an exterior. These are often, with many things, you're going to see it in its acronym form, which is just, taking the first letter of each word. So you're going to have people talking about IGPs and EGPs, and that's just your interior gateway protocol and your exterior gateway protocol. So again, if we're looking at routing protocols as like these overarching thing, like routing protocols is what we're looking at. It's the main point, and then you go underneath it. So one tier down from routing protocols, there's going to be two possibilities. You're either going to be an interior gateway protocol, or you're going to be an exterior gateway protocol, right? And just like the name implies, interior is going to be running within an organization. And an exterior is going to be routing between organizations over the internet, right? So exterior, internet. Interior, within an organization. That's pretty easy to wrap your brain around and not have to spend a lot of time like making that connection. It's in the name, right? Interior gateway to protocols, we're running it within the organization. Exterior gateway protocols, it's outside of the organization. If it's outside the organization, it's on the internet, right? So it's running over the internet. If it's running over the internet, it's exterior. It's outside your organization's control. Interior, within your organization's control. Awesome. So the interesting thing about this is I guess there used to be a lot of EGPs. That's your exterior gateway protocol. But as of now, so currently the only EGP being used in use is the Border Gateway Protocol. And this is something we actually use pretty often, I would assume. So your Border Gateway Protocol is going to be used on the router on the edge of your network. So the router that's nearest to the internet. And you're going to put your Border Gateway Protocol on that router. And this is going a little bit into depth, but essentially what you're going to do is you're going to log into that router. When you log in, you're going to be at the basic screen. You're going to enable. Let's just do this like it's an actual command set. So you're going to enable. That's going to bring up your router hashtag. Privileged exec. What up? What up? At that point, you can go to your configure. I think you want to configure terminal on this one. Man, I should have looked this up before I went into it. So we're going to go configure terminal. That's going to go into router config. And at that point, I think you can put this command in. This is something I'm going to have to check for on the next stream as well, so I know I have it right. Now there is a command. It's further down. I'm jumping ahead of myself. Show IP route will show you the routes. Where's the command for? Oh, IP route. It's just IP route. Beautiful. So we're going to put in IP route That's a comma. And so this first number represents the network. Wait, the first number is the network you want access to. So if we put 0.0.0.0, that's kind of like a wild card. It's saying like anything that hasn't already been found on this routing protocol, put it here. And then the second number is your subnet mask. So again, we're putting 0.0.0.0, which kind of opens it up. It's saying anything that you haven't found where to route it, put it here. This is your border gateway, default gateway. This is where it's going to go. And then this last number, so it's going to be 3 dotted decimal numbers. First number, again, is the network you want to access. Second number is the subnet mask that you want to place on it. And the third number is the address that you go to get to that network. So again, this is going to be placed on the border gate. This is going to be placed on the router that's right on the edge of the network. So the next the IP you're going to use is the one that your service provider has. So it's going to be like, I don't know what it would be because I'm not your service provider, but this third number is going to be service provider IP, also known as a ISP, internet service provider, but it's going to be like I don't know, we could just put something in here, 192.240.41. So that's what it would look like. We'd run that, and that would create a border gateway protocol. And again, this is just going to be on the very edge router. This is going to be on the router closest to the internet. And that was jumping ahead a little bit, but I wanted to talk about that while I was in the way, because again, this is the only exterior gateway protocol in use today. So apparently there used to be a couple of them, but as of now, it seems like if they're asking you, so if you get asked on the test, on the certificate test, what protocol would we use for exterior gateway, it's always going to be your border gateway protocol, because that's the only one that you use on it. That's the only one I've seen in the learning material so far. So unless they've hidden a different protocol a little further in, I think that's all you have to worry about for external gateway protocols. So let's talk about internal gateway protocols, and I'm just going to use the acronym IGP, because there are more than one of them. So IGPs, again, if we're thinking about breaking this down by tiers, so we started at routing fundamentals, and then we went down kind of like two different tiers. There was the interior gateway and the exterior. The exterior only breaks down to one further level, and it's the only thing it has. So if you think like exterior breaks down to your border gateway protocols, and that's the only choice you have. Whereas the interior, I'm trying to keep my hands in frame so I'm not just like out here. Interior, it's going to break down to two different main types. So you have within interior, and again, these are protocols themselves. So we're talking about protocols within protocols, and this part confuses me just because it's like, it seems like a nesting doll situation where we got a lot of stuff inside of a lot of stuff going on here, and it's all operating seemingly at the same level. So computers are magic, man. Sometimes it's just like, wow, impressive. So again, we have two main types within your interior gateway protocols, IGPs. It's going to be your distance vector routing protocols. Again, it's a protocol. And the other option you have is a link state routing protocol. Protocols, because again, there's multiple protocols that fall within each one of these. Whoa, right? Like, it just keeps going and more keep folding in. With distance vector routing protocols, so it's going to advertise all its known networks with the distance to that network to every other router that's directly connected. So if the interface from one router is running to the interface of another router, or it gets there through their networks, those will be able to broadcast a distance vector routing protocol to one another. And what it's going to say is one router will say, hey, here's all the networks I can get to in my routing table. And here's how many hops it takes me to get there. Hops is distance. How many hops it takes me to get there. And that's all it shows the other router. And the other router can base that information. Well, I need to go there, and it says you can take 2 hops. This one says you can get there in 4, so I'm going to go through you, right? Like, that's kind of the information you're working with. But in that, you can already see that the router doesn't have access to the network topology on a whole. It only has access to what the routers around it are telling it. And that is often called routing by rumor, because you're not getting an accurate, you're not sure that you're getting an accurate picture of the network. You're only getting what the other routers are telling you, and they're only telling you like very minimal information when it comes to this. So again, I'm gonna have to work on this information a little bit. This is new information to me, so I apologize if any of this is not completely accurate, or if I'm not explaining it in the most easy to digest method. But hopefully we're gonna only improve from here. So distance vector routing protocol, distance in the name, just like it implies. We'll get into that a little later. Sorry, jumping ahead of myself. Let's show the other type of main protocol that falls within the interior gateway protocol. So again, exterior gateway protocols only have one protocol under it. It's the border gateway protocol. We covered that in the beginning. Now we're going over the interior gateway protocols, and it has 2 main types. The first one we just covered, distance vector routing. The second one is link state routing protocol. So link state routing protocol advertises itself and its, how would we say this, interfaces to its directly connected neighbors. So just like distance vectoring, it's still only telling the routers that are directly connected to it. The only difference is the router, they continue to pass that information down from router to router. So with distance, the router only knows by rumor what the other routers around it are able to access, right? It says, well, based on what this router told me it can get there in such and such hops, I'm going to take that as it knowing that for sure. Whereas link state, each router passes its information and all the information it has onto the next router. So as this information gets passed around your network, it's actually mapping out your entire network for all your routers. So every router will have an accurate picture of what your internal network looks like, right? So everything they have access to, they're gonna have a map of that, kind of like not a physical map, but like a routing table, which if you were to label it all out would be like a map of your network. So we can already tell that distance vector routing, like it said, routing by rumor, is not always going to be, the tables that the routers have are not always going to be necessarily up to date, accurate. You might have dropped packets because of that. It might have to find new routes, but it's also not near as much information, right? Like you're not passing as much, so your routers don't have to hold as much information. So that's going to be less usage of memory, which, I mean, you'd have to have a lot of memory, but still, it's less usage of memory. Truthfully, factual, it's going to be less usage of memory. It's also going to be less CPU usage. It doesn't have to go through as much data. It doesn't have to do as much archiving and reading and writing. That also means less power usage, probably on like the minuscule amount. But still, if huge network that's constantly doing this stuff, I mean, I guess that stuff can really add up. Huge network, again, the memory can really add up. If all your routers are sharing all their routes within the network, you can see how that could create like a very large table, which could have its own issues depending on memory size of your routers and buffer issues and things like that. So we can think of this as every router learns a full picture of the network. So again, this is just one step into interior gateway protocols. So if we think of routing, there's two very large types of protocols. You have your interior and your exterior. Exterior only has one option, so that's awesome. That's great for testing. That means if you're working with exterior or working with border gateway protocols. Interior, we just found out, has two main types within it. So if you're working within a network, you're either going to be working on a distance vector protocol or you're going to be working on a link state routing protocol. And so let's get into a little bit more of what that means. So IGPs, your interior gateway protocols, there's two types of routing protocol. I mean, there's probably more. There's probably like ones that are outdated. Currently, there's two that are in use, and that's RIP and... Let me make sure I'm doing this right. Ospf. Nope, that's not right. First of all, let's get this right. So, distance vector routing protocols. RIP is a distance vector, and EIG, am I on the right? EIG RP. So let's go over which each one of these means. RIP is your routing information protocol, and EIGRP is enhanced interior gateway routing protocol. Okay. Whew. So both of these are going to be your routing protocols that use distance vectoring as their metric. Let's see. Then you have what's going to be using your link state routing protocols. So within link state, we're going to have OSPF, which is... I like this one because I feel like it's easy to remember for some reason, which is open shortest path first. Love it. And then the other option you're going to have is IS. This was prior to everything that was going on. I guess we could call it dashish. That might be a little much for anyone. So ISIS is the intermediate system. It's the intermediate system. Dang, man. You know it. I guess they could have called it the IS squared. I would have liked that a little bit more, but you know, IS to the power 2. All right, so let's go over what makes these a little bit. This is a good. So this kind of right here. Let's go like this. So this is like essentially just this little section right here is all the routing protocols I've learned so far and how they fit. So if we think of the IGP and the EGP as the two bigger brackets within routing, EGP is exterior once again, and that's just going to be border gateway. Love it. Love exterior because it's only got one choice. Give me those questions on the test. And then the interior gateway protocol, you're going to have either distance vector or link state. And within distance vector, you have RIP, which is, my understanding, a bit outdated, not used too much. Smaller networks, and we'll go over why here in a second. EIGRP, Enhanced Interior Gateway Routing Protocol. If I'm not mistaken, this is Cisco. This is specifically a Cisco protocol. So why they have tried to open it up to other vendors, it's still mainly only used within Cisco networks, because if you're using it, all the devices have to be able to use it. So all these other routing protocols, OSPF, ISIS, and RIP, I believe are all open source, which means all the vendors, all the different people that build routers and switches have access to the base code, and they can implement it within their systems without a problem. Whereas EIGRP is Cisco specific, and I guess they've been trying to get other people to carry it, but it's still not open source, I don't believe. So if you're going to be using EIGRP, it's important to make sure that all the systems within that network are capable of using it. Otherwise, you're going to have a lot of problems. So drawback of this one is it's Cisco only. Drawback of this one is it's outdated and typically only used on shorter networks. Let's see. Path vector routing protocol. So there's a lot of different ways for routers and systems to learn paths. There's if you just want to look at it the very generic way, there's dynamic and static. So dynamic are like these routing protocols because they are doing it, they are passing the information. The protocol is running and it's causing them to gather this information and pass it between each other so they can create these network topologies, or in the case of some of them that don't get that much information, they at least know how to get places, right? And they do that all in their own. So if you have if you have a router go down from a power outage, or like the interfaces gets corrupted, so information can't get through without being corrupted. For whatever reason, you lose a link within your network, so you lose a node along a path. If it's a dynamic routing protocol, it's going to be able to, as long as there is a path around it, it's going to find another way to reach the destination it needs to reach within your network. And it's just going to update its tables. It's going to say what we thought was the shortest table, remove that because we lost. For whatever reason, it's no longer the shortest. This is the new shortest. It's going to use that, and it's also going to update, depending on the protocol, it's probably going to update the routers around it and say, hey, we're no longer using this one. Hey, we're no longer using this one. And you, as an administrator, you'll probably be in some central office, and all the errors over all the network will be kind of brought to this one place where you can look at it, and it will say, hey, we had to update this routing table, packets were lost in the interim, stuff like that. So you'll be able to see, something's wrong along this pathway, something's going on. You're gonna have to figure out which device it is, why it is. Then you're gonna have to go into like the old troubleshooting mode and try to get that link back up and established so you can get that shorter path up. You can get any other IPs that were allocated to that. If it's a router to that subnet, you can get that back online. So if it's like the accounting department or something went down, yeah, super important, super important. The other way is static. So when you saw me, this is me entering in a static route. So I'm doing a configured terminal, and then I'm putting in my own IP route. So this is for the border gateway protocol, but you can build your own routes between routers too. Like if you specifically want if you specifically want, so the first number is the network you want access to. So if the accounting department, if you want specifically your I don't know, your admin department to specifically network through your accounting department for whatever reason, you would choose the destination network. So that'd be your first number. Your second number would be the subnet mask you want to use on it. So I want to go out to the, let's say I'm going out to the third octet. Maybe I'll do like a 240. And then the last IP is the next hop for that router. So it's not the destination IP, it's the next hop that will get you to the router, that will get you to the next hop, that will eventually get you to that IP. That part was hard for me to kind of wrap my mind around, but essentially what you're doing is you're entering in statically the next hop you want this information to take, as long as it fits within these parameters. And then you'd have to go to that router and you'd have to put in a static IP route there carrying it on. So you'd still be using this as your destination, you'd still be using this as your subnet, but now your third number would be the next interface along. So if you're going from router 1 to router 2, that'd be like this one, so it'd be like 1.1, and then the next one would be like the next network over .1, the next network over .1, because you'd be going into that next interface of the next router, and that router would be grabbing that information. It would look at the destination, it would look at the sub, and then it would specifically spit it out over to the next device over. And this is static. This is if you want this information to follow this route. You are building this route yourself. So you have to manually go in and build it. So if you have a really tiny network, or if you have some information that you really need to follow a singular path, you can do that. But you can see how in really big networks, manually entering static IPs would be insanity, unless, again, it's for a specific, very necessary route. Otherwise, it's just like, because again, so the difference here is like if one of those systems went down, the static IP it doesn't have that information coming in from different routing protocols to update the network, right? So it's still going to be like trying to send it out this interface to this device that's no longer online, or it's dropping packets for whatever reason. The line's bad, the power's off, the IP address got messed up, corrupted, whatever the cause, but it's just gonna keep trying because it's a static route and it doesn't know any better. There is no protocol there to allow it to build that path structure back up. So things to keep in mind. So that's just dynamic versus static. Dynamic routes will update based on routing protocol in use. Man, having problems spelling protocol. So static won't update other routes. There's another, so if I wanted to, let's say I logged in to a router. Let's just bring this down to the next page. So router, enable router. I can do from privileged exec is the show, right? think it's show on this level. Show IP route, and I can hit enter there, and it will show me all the different routes associated with this device. And there's going to be different types of routes. So there's going to be a C, there's going to be a L, and there's going to be a S. Well, there's a possibility of a C. There's a possibility of it. Well, there should always be a C. Because C is anything directly connected. So this is going to be anything plugged straight into the interface. If you're plugging in fiber optic cables, if you're plugging in Ethernet cables, if you have a wireless access point plugged in, that's going to, oh, that's an interesting, yeah, I guess it's a directly connected interface. So that'd be connected routes. So these are routes that are directly connected to that router. Then you're going to have L's, which are local routes, I believe is what that stands for. Uh-oh, I'm going to have to look that up. I'm going to put a thing there so I know to look that up just in case. And then S is going to be, what did we just go over? Static routes. S is going to be your static routes. So again, when you show the IP route, a bunch, I wonder if we can, I wonder if it'll pull up like a, yeah, here we go. Oh man, love Google. No, just give me the, man, just give me the image. All right, so here's, he's in a router. They're in a router. I don't know if it's a he. That was, come on, Nate. They do a show IP route. Here you have a C for connected. You have a S for, oh, it even tells you. Oh, look at this. It even tells you everything. What? Look at this. We can even, okay, so I is the interior, what does that all stand for? I already lost it. Interior gateway routing protocol. R is your RIP routing protocol, which is your, what does that stand for again? Routing information protocol is RIP. M is mobile, so that's its own thing. I haven't touched that yet. B is BGP. That's your border gateway protocol. So that would only work under an exterior, not an interior. EIGRP. That is the, that's the Cisco only, right? Yeah, that's the Enhanced Interior Gateway Routing Protocol. You have, oh, look at this, X. So this is an external version of the Cisco protocol. So this must work outside of networks. This is interesting. This is information not necessarily covered under the course. It's not necessarily going to be asked in the exam, but it's neat that I can look at this information and kind of get some information out of it. So OSPF is Open Shortest Path First. God, I love that one for some reason. I just don't forget it. It's going to be represented by an O. So then, I mean, we can go through all these. Looks like some of them are outside my level. But here's what happens is, so first of all, it says gateway of last resort is not set. So what we can gather from that is this router is likely not on the exterior. It's not right next to the internet service provider, right? It's one that's further in, because the only time you're going to set up a gateway of last resort is if it's on that. Well, maybe that's not the only time. I think it's the only time. I'm going to have to look into that. But then we could see within this, so we know, oh, geez, I keep clicking it. So we know that this router is directly connected to 10.0.0.0. Oh, it even says directly connected. And it even says which port it's on. It's on the fast Ethernet 0.0/0, sorry. And then it says we have a static. So someone set up a static route right here. And here's the network they're trying to reach. Doesn't give a gateway. Or it doesn't give a subnet mask. Sorry. This is not how I've seen it. So typically there'd be a subnet mask right in here. Maybe this implies something like along the same mask or something like this. And then here's the actual, the next IP. So this might be the destination, or more than likely is just the next system along the line to get to that destination. So again, when you put in a static, you have to put it in at each step along the way. So you have to put in a static that says coming from here, going to here, going and then going back. Like, it's very intensive, but at the same time, you know exactly what's going on. I mean, as long as you can keep all that coherent, because some of these networks get really big. So, and then we have another C, which is directly connected. This is an IP serial to. So this direct connection here is probably an administrative port, because we can see it's a serial. So this is if someone's like, I wonder if you can telnet or SSH over a serial, because it does have an IP. So that's interesting, because I don't think you need. My understanding that the CLI, the command interface, CIL, sorry, command interface line didn't require an IP address. It worked at the physical bit stage. So that's interesting. But this is probably just me misremembering a little bit of information. I have yet to put this all together, so apologies. But again, that was just to give you an idea, give myself a refresher of what it looks like when you pull up a show IP route and how it gives you all this information. Whatever's already on the router, it's going to give you that information. So as long as you know how to read this information when it comes up, as long as you know how to use the question mark to bring up your different commands, you can see how you can kind of stumble your way through this. I mean, certainly that's not what you want to do in the workplace, but when you're putting together practice labs and just playing around with packet tracer, like really taking the time to just play around with it, look at these different screens, can be very beneficial. And that's something I'm still doing. I'm still playing around with packet tracer quite a bit, because sometimes following the labs just doesn't do it for me. Like, that sometimes I get lost in just following the steps. I'm not necessarily making the connections or utilizing the information in a unique way that allows me to remember. Not even in a unique way, but actually like pushing myself on the information, not just like monkey see, monkey doing it. I mean, there's, especially in the beginning, monkey see, monkey do can be very beneficial. But you have to, at least myself, to get a deeper, not just understanding, but just to remember it better. Monkey see, monkey do often is one of the first things I forget, because I don't have that that corresponding information that kind of sets it up, you know. I don't know how to say it. I'm sure you understand what I'm trying to say. Dynamic routes will update based on routing protocol. We went over that. So routes can also use, I think static and dynamic. I'm pretty sure both can use summary routes. So instead of making a very specific, you're going to this singular IP on this singular subnet, you can make a summary route where it covers, it's basically a subnet mask, essentially, is you're just saying anything that falls within this subnet network can be routed through this port. So you're not typing out like all these different nets. So if you had like, oh man, what's a good way to do this? I don't know subs well enough to, oh man. 0.0, and then let's say 172.15.16.0, 172.15.32.0. So if you had these are three networks that all could fall within the same subnet. So instead of doing a static route for each one of these, which again would be your first number is the network you're going to, second number is the subnet mask, the third number is the port, the next nearest port that will take you there. So instead of typing out a static route for each one of these, you could just say 172.15.0.0/ slash, let's see, that's going up by 16s. That'd be slash 28, but it's on the third. Man, you know what I mean. I gotta work better on these. I don't know exactly what slash that'd be. That'd be like a slash 24. No, that'd be a slash 23, 22. That'd be a slash 22, I think. But I'm not 100% sure on that. So anyways, you can make one route that goes through this. And it would take all the information that would be going to this through one route instead of making 3 different static routes. So again, that's just summarizing 3 different sub networks into a larger network. And you're not actually changing those networks. You're just showing where those networks' data should be funneled through. So it's just a way to create a larger funnel without having to enter in as many addresses. Clearly, you have to know subnetting networks, like how networks fit within each other. Clearly, I'm still not in a place where I'm very confident in that. So, we're gonna work on that. But that I understand the overarching way that it works. I can't necessarily. I'm not very good at the subnetting part yet. Working on it. So I did the show IP route. It shows you what each connection is. So yeah, okay. So we got all these different routing protocols. What makes them different? Well, that's going to be. That's going to be the routing metrics. So what I mean with that is with multiple paths available, which is the best one? And so the best one is going to depend on which routing protocol you choose to use, right? So what do I mean by this? I mean, no matter what metric you used, the lowest number is better. So, let's go over this first. So for distance routing protocols, like RIP is going to use hops as its metric. So that means regardless of how quick the line is, how much bandwidth is between the 2 connections, that's 1 hop. So one router to one router, that's 1 hop. No matter if this is 100 megabytes, 10 megabytes, 10 gigabytes, doesn't matter what the throughput is, it's 1 hop. So you go one more router over, that's another hop. That means it takes 2 hops to get to that router, regardless of how fast the information travels between the 2. It's just the amount of hops. So you can literally just count how many routers away your destination is. That's how many hops it is. And then, of course, because it's a network, there may be multiple paths to that destination, and it's just going to choose whichever one takes the fewest hops. That's it. That's what RIP does. It says I can reach destination A in 3 hops or in 7 hops. And it doesn't matter if the 3 hops are all over 1 megabyte connections and the 7 hops are all over giga, fiber connections. It doesn't matter that even though it's 7 hops, it might take significantly less time. All that matters is the amount of hops. And for that reason, that's kind of why people are like, RIP on RIP. So RIP actually, here's another interesting thing, defaults anything over 15 hops away is unreachable, right? And if we're thinking about networks, 15 hops is not a lot. Like, honestly, not a lot. So the fact that RIP thinks that anything over 15 is just like gone, That's why earlier, outdated in smaller networks. That's why I said RIP is outdated and smaller. Because when you're defaulting to 15 hops, like, you have to have a real small network. You have to be one that it helps to know where everything it is. It helps that all the connections are the same. And what I mean by that is all the throughputs on the connections are the same, because it's not looking at that. It's just looking at how many hops, not even like distance of those hops, just how many hops, period. So like it can get wonky really fast with RIP. Again, best used in small or test environments. So it's not to say that you won't use RIP. There may be cases where you use RIP within your network, within like sandbox modes or something, like a smaller sandbox network within your network or something like that, for experiments, testing purposes. But I don't foresee a lot of use with RIP. EIGRP, that's the Cisco specific routing protocol. What did it stand for again? Let's see here. The enhanced. It's enhanced. It's enhanced and advanced. It's the Enhanced Interior Gateway Protocol. And I say that because Cisco actually considers this an advanced distance routing protocol. So they consider it much better, on a different level than RIP. Even though both of these fall within your distance routing protocols, Cisco wants you to know that this one is much better. Not only is it enhanced, it's advanced. Granted, this is a Cisco test, so they might be a little bit like, on their own side. And again, all the devices on the network have to be able to use this protocol if you want to use it. So, yeah. Okay, but so for this metric, it's going to be using. So even though it sits under distance routing protocols and we think of that as hops, this one actually uses bandwidth and link delay to calculate the metrics. And again, the lower the metric number, the better. The lower one is always going to win. It's like latency with your games when you're looking at your ping, your latency. The lower the number, the better. It's like playing golf. The lower the number, the better. But the interesting thing is, even though this is distance routing protocol, instead of using hops, it's going to use bandwidth and link delay. So what do I mean by that? Bandwidth is, like I was saying earlier, so it's going to say it's going to look at like how much throughput it has on each connection. So if one is like a gig and one is like 10 megabytes, it's going to score the gig as much faster, as a much better choice for its next hop. So that's going to get a lower number. Whereas the 10 megabyte line, which might be slower for transfer, you might have more corrupted information on that line as it gets bogged down, you're going to have a much higher number on that. So it's going to be less likely to use that higher number hop. Because again, it's building these networks out, right? So it's going to have, these routers are going to have a lot of different choices for paths. This is how it chooses the best path based on the protocol. Whew, a lot of information in here. So then we have the Ospf. And these are all, so all four of these are going to fall under the interior gateway protocols. These first two are going to be distance. So this is distance. Even though we don't necessarily think of the metric that uses one as distance, it still falls under the distance routing protocol. So we just have to remember that as it is what it is. So the Ospf is actually a link state. So this one's going to fall under link state. Um, what's that stand for? Open shortest path first. So link state is going to sound a lot like what I just said EIGRP function off of, only it's much more accurate to the actual link state. So this one, let's go back to EIGRP real quick. So it not only does bandwidth, but it also does link delay. Link delay is not a number that it tests for. So as a networker, you might think that it's sending out like just packet information to test how not only how fast that line is, but how like how in use it is. So like how much bandwidth within that line is already taken up, like how accurate or how quickly are you going to be able to inject information into that line, and then how fast will it travel over that line. So link delay, it doesn't actually continuously test for the link delay. What it does is it just sets a default number. It says this is 100 megabyte running over a such and such interface. I'm going to score that as a 2. This is a 10 gigabyte running over a single fiber optic line. I'm going to score that as a 1. This is much faster. I want to choose this if at all possible. But it's not actually testing that. It's not in real time testing those links. So it's just a default number that's given out when you choose this routing protocol. I'm assuming it happens as you deploy it on your network. So it just does that initial test, and it just says, all right, this is what we're going to link delay these. But OSPF is a true link state. So it's truly looking at just the speeds of those network lines, and it's going to choose the fastest path. So if we think of RIP as the shortest path, the fewest hops, OSPF is going to be the fastest path. It's going to be choosing all the gig lines, all the fiber lines. It's going for whatever can get it there fastest, regardless of how congested, there's a good word, how congested those lines are. So now we're talking about ISIS. It is also a link state. So far, if you're following along, for the interior gateway protocols, we have 4 different routing protocols. 2 fall under distance, 2 fall under link state. Awesome. Not necessarily the ones that you would think would fall under each one falls under each one. So it's important to remember that the Cisco one, while it seems more like a link state, is actually still considered distance. It's also specific to Cisco devices, so that's something to keep in mind. RIP is also distance, but it's old and it's typically only for smaller test environments. So again, these 2 you're not going to necessarily see too much. However, OSPF is the most common routing protocol you're going to find out in the world at large. So the reason that OSPF typically beats out the EIGRP is because it is open source. So that means any device manufacturer can include this protocol on their device. It's going to run OSPF. So it doesn't matter if you have a Cisco router and a Netgear switch and some other company's server, they're all going to be able to talk to each other on OSPF. Whereas if you had that same network makeup and you were trying to run EIGRP, those other devices, the Cisco router wouldn't be able to route to them. It'd be like, they're not Cisco. Why not? Whoa, hey, come on, man. Why you got me hanging out with these less than Cisco items? So, it's a little hoity-toity, that EIGRP. So ISIS is link state as well. Man, so here's another one that's just really confusing. ISIS defaults all links to an equal value. What does that mean? If all the links are at equal value, then how does it determine what the best path is? This is going to blow your mind. By hops. What? Why? I don't know. It would. So in my mind, in my fragile, unexamined mind, I honestly want to put RIP and ISIS under distance because they both use hops, right? And I want to put EIGRP, Enhanced Interior Gateway Routing Protocol, and OSPF, Open Shortest Path First, and I want to put those two in link state because that's how they actually seem to work. But apparently I just haven't gotten far enough in the course material to understand that this is a different kind of hops. This is a different kind of, I mean, it's not, but for some reason, I mean, for as much as I know now, it's not, but for some reason they're put under these. So this is just something that you have to repetition, put it on a flashcard and hope you don't confuse it on the test. Because this is something that I could easily talk myself out of, right? This is, so this is going to be one of those repetitions. So again, these are all dynamic routes. These are all protocols that are going to be able to build their own routing procedure within your network. So you turn them on and they just start talking to each other. They start talking to all the other devices. And based on how they see the shortest path in the network, based on what metric they use, whether it's specifically just hops and they have a 15 hop maximum, or if it's based on bandwidth and link delay, or if it's based on the fastest possible path, that's bandwidth specifically, or if it's based on default values, hops again. So the interesting thing about ISIS is that it defaults all links to equal values. So you can go in as the network administrator and you can change different interfaces to different values. So if you want to make one path the better path, you can do that. So that's an interesting way to get kind of the best, not necessarily the best of both worlds, but you get a little bit of both worlds. So if you want it to be based on hops, but you want certain hops to be excluded or you want certain hops to be included, you can just give them very high or very low scores on that metric line. So it's going to all default to the same, but you can always choose to give one of those interfaces a different score or all those interfaces a different score. But again, you have to remember that you're going to have to log into this machine and you're going to have to change this manually. So that part of this is not dynamic. The default link is not dynamic. It's not going to change dynamically. You can't run that'd be really cool if you could run like an API script or something like that would base it on network speeds. But as it is, it defaults to all equal and then it just goes to hops. So this is purely hops. This is hops plus what you're willing to put into it, like manual changes to the default links. This is the fastest possible path. This is the fastest possible path with a couple of caveats based on link delay and things like that. I don't remember Neil saying anything about manual calculation of this, so I believe this is all dynamic on this one. All important information to try to keep straight for the tests. So these are all dynamic, but then we have static routes, and again, these are ones that we put in ourselves. So we would just log into the system and we would say IP route. And then we could put so x equals destination network. I think it's network, right? Yeah, destination network. Y equals subnet mask. Z equals next interface IP along the path. And that would be how you enter in a static route. Again, so you're going to have to go into your router. It's going to be in its base mode. You're going to have to enable to get to the privileged executive mode. And then you have to configure terminal to get to the global configuration mode. And from here, you should be able to enter in your static routing protocol. And again, so this can be either a very specific one-off, or this could be a summary. So depending on how big the subnet you use in here, the Y value, depending on the Y value, this could either be a kind of like a direct routing protocol to a single subnet, or it could be to a larger subnet. So if you had like, well, we'll wait till I have a good packet tracer lab for that one, because trying to describe that without a drawing or something could be all confusing. So static routes obviously have a huge drawback, and that you, when I say you, I mean like the network person has to configure them. And also if something goes down, if one system, if one device in the line of that static route goes down, that whole static route fails. So you might have entered in this static route into like 10 or 15 different routers to route this information through, and then one of the routers right in the middle drops. All those routers are still trying, they have no connection, but they're just going to keep trying. So all that information is just going to be no bueno. You know, the system's going to be throwing you up errors, being like, we can't get this information in or out, or can't update it, whatever the system's trying to do. It's going to be like, no. So summary, again, is summarizing a bunch of smaller subnets into a larger one. So it's just taking a bunch of little routes into a big one. It's saving the network administrator time, as long as they all fall within one subnet, as long as they're all going to the same location or going through the same area together. It's just a quicker way of putting in this information. So instead of entering in like 6 or 7 routes, you enter in one. There's something referred to as equal crossload. So when, let's say there's 2 different pathways that information can take. You're sending out information to Twitch or whatever, and you have 2 different pathways to the Twitch servers. Equal crossload can take that information and use both pathways. So it's going to keep all the same session information within one pathway. So it's not going to split. It's not going to take one application's data and split it over both lines, because that's going to lead to issues when it gets there, putting it back together in sequence, making sure that the checksums are in order, making sure that none of the information got corrupt. That's adding too much into it. However, if you have 2 different streams of data going to the same location, and that happens all the time, because think about like when you're working with FTP, you have 2 different ports, right? You have 20 and 21. 21 is your control port, 20 is your data transfer port. So you actually have 2 different streams of information running to that FTP server. So if you had 2 lines, you could theoretically use equal cross load to split that information and send it down each like send port 20 down one way and port 21 down, the information coming from those ports each down their own pathway. That's completely able to do, and you can see why you'd want to do that, because if a network is being overutilized, if one portion of a network's being overutilized, if the bandwidth is getting drawn out for whatever reason, like maybe that section of the network is due for an update and no one like put updates periodically for system to system, and they just did it all at once. So you got like 200 machines calling in for an update, and that network is just slogged. There's just nothing moving through it. Equal cross-loading can take the very little bit of information and throw it down that line because it knows like this will fit, and then take the bigger information, the port 20, the bulk of the data, and say, well, this line's a little bit slower, but it's not as packed, so we're going to send it down that way, and that's what equal cross-loading does. It only works if the information is going to the same destination and on the same subnet mask. So it has to be on the same subnet mask. It has to be on the same network, greater network, because it could be smaller subnets, I believe. And it has to be going to the same IP, the same destination overall. Yeah. So this was a very, very basic overview of what I've learned so far in routing. There's still a lot more to cover in just the routing basics, routing protocols, but this is a pretty good jump on that start on that jump start. Real quick, I just want to do some review because it's always good to do reviews, especially on some of the stuff that you're just consistently going to see through networking more so than just on the CCNA. So real quick, we're going to do OS high levels like we always do. We're going to start with the mnemonic. How do we spell that? Mnemonic. No. Mnemonic. Well, however you spell it. I think it starts with an M. Maybe an N. Mnemonic. Mnemonic. Anyways, it's please do not throw sausage pizza away. And that's going to be physical, data link, network, transport, session, presentation, and application. And of course, we don't really care about these higher levels. So we only really care about physical, data, network, and transport. And real quick, we're just going to do some more. So physical is going to be your bits. Anything traveling on physical is going to be referred to as bits. It's going to be your copper lines. Your copper lines are Ethernet. Ethernet is made out of copper. Ethernet lines are made out of copper. Your coaxial and your fiber. Two options, single, multi, which comes in single and multi-mode, and we've gone over that a couple of times. Data link, which is going to come in over frames. We're going to call them frames. This is your layer 2, so it's going to be MAC addresses are going to be your major routing. How you route information at layer 2 is based a lot on MAC addresses. It's based on frames. Ooh, let's talk about what operates on level 2. Switches operate on level 2, and if we want to be accurate, technically hubs operate on level 1, but they're no longer used. No one uses hubs because they work at half duplex and they shout everything out all their ports. It's a waste of money. With switches so cheap, everyone just puts switches in for hubs now. Switches are on level 2. Sometimes they can be found on level 3. Those are special switches. This is going to be routing within a network because we don't have access to IPs, right? So level 3 is going to be your packets. It's going to be working on IP addresses is how it's routing the information. Routers work on level 3 as well as layer 3 switches. But those will be specifically notated especially if they're in the certification certification test, they're gonna talk. They're gonna specifically say it's a layer 3 switch. They're not just gonna throw in a layer 3 switch and not say anything about it. Depending on where you work, you might see these fairly often, but I think typically you're just going to see routers in place of a layer 3. You're just not going to see a lot of layer 3 switches out and about. But it doesn't matter because they work essentially like routers. They work on the layer 3, so they're going to work with IP addresses. They can route by subnet outside a single network. Yay! Transport. Let's get the... Transport works as segments, is what we're going to be talking about. Any information falling through transport. Transport is your UDP TCP is what you're working with on layer 4. So whether you're using UDP, which is, as we talked about, is doing the best it can, or TCP, where you have flow control and error correction. You want to use those for different things. So if you're working on like the VoIP, your video and voice over internet protocol, so those like Cisco phones, those are all UDP, of course. So if you're troubleshooting a Cisco phone, you're going to be working on UDP. If you're troubleshooting information that needs to be error checked, that needs to be flow controlled, you're going to be working with TCP. Not a huge difference in the layout because they both have that dotted decimal format for octets separated by dots. What else about layer 4? Layer 4 is also session multiplexing, and this is for routing information within the system. So as applications use information, they're going to be sending it out. And it might have, so if you're sending out like FTP information, your destination port is going to be 20 and 21. But what you send it out of from your computer is actually going to assign it a port in a much higher number. It's going to be like 8,994. And that's so it can keep track of that FTP data. When information comes back, it's going to say, I just came from port 20. I'm going back to this port 8,986 or whatever I said it was. And that's how it keeps track of that information. That's what session multiplexing is it's how you're able to send out all this stuff from your computer and how it's all able to come back in and it doesn't get confused. I can open 3 different Google browsers. I can Google something different on each one and it's not going to interfere with each other, right? Like, that's amazing. And that's all, well, not all of it, but it's great. You got to be thankful for session multiplexing because it allows those abilities with these computers. Pretty amazing. So tomorrow I want to go over routing protocols in more depth. As well as introduce VLANs. So this is when we're going to start getting into our virtual networks, which is really cool. This is a lot more, this is a lot newer information. VLANs are, I mean, they've been out for a while, but they're definitely out of all the stuff that we've learned so far. It's the more, it's the newest of the information. And it is, virtual networks are on the up and up, like, pretty amazing. So it's definitely something that I'm going to make sure I invest myself in and know. Real quick, let's just do, yeah, it's been about an hour and a half. We got a little, let's do a little bit more. Let's just do a couple subnetting practice questions just to see if I can get myself, man, that's not the worst one. All right, here we go. What's the first valid host on a network? So let's copy this information into here. Actually, let's copy it over here. So if this is, all right, so this is our information. What does it want us to do with this? What is the first valid host on the network that, well, let's do more than that. That's a good. Let's do a network broadcast IP range first host. So first host is going to be the first number on the IP range, and that's just so I can include the answers to the actual question it's asking. Cancel. No, I don't want to merge all those. I just want to merge it like this. Wonder if there's a shortcut for merge. I bet there is. Oh, wait. I could just merge horizontally? Yeah, it's a merge. I could have done them all. Dang it. Look at that. We're learning. But I didn't do them. So, all right. So first, let's do... Man, I'm all over the place here. Let's convert /21 into dotted decimal subnet mask. So /21, we can go up here. I changed this a little bit so it fits on one screen. Normally we'd write all four of these out in a line. So /21, we're gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That's what a /21 is, essentially. Of course, a much easier way to do this is we know these are octets. So 8, 16, we take 16 from 21 because we know the first two octets are going to be completely full. The remainder 3, so we fill all the way up to the last 3 spots. That's another way of doing it. We know this is going to be 255.255 because these are completely full. And then we could add up these, but when we're so close, an easier way, a way that I would look at this bracket right here, this octet right here, I would take 255 because we know if these were all ones, it'd be 255. And I'm going to subtract 4, 5, 6, 7 off of that, right? See how I'm doing that? So that's 251, 250, 248, right? 48. Yeah, that's 248. Okay. So this would be, oh, where'd it go? Oh, here we go. This would be, so for a /21, this is what the dotted decimal would look like. Here we go. Let's see if I can do this vertically. Nope. I wanted to do it the other way. Horizontally. There we go. Okay. So let's take, we know we're subnetting this in the third octet, right? So that means that the network is going to be /21. So we go, how do we do? Oh, okay. So one way to do network that's kind of easy is we can use this same formula up here for the network. So what we do is it's a /21. We know that's going to be right here. So we take the third octet of the IP address and we place it in here. So 229 definitely fits into 128, or 128 definitely fits into 229. I'm gonna pull this up because why not? That leaves 101. 64 definitely goes into 101. 32 definitely goes into 37. 16 does not go into 5. 8 does not go into 5. 4 does, but we don't really have to worry about it anymore because this is the /21 right here, right? So we can take, this is going to seem like magic to anyone that doesn't understand this, like it did to me for the first time. So that's our network. And that is magic. And I'm not entirely sure how to explain it. What we do is we take the subnet mask and whatever the mask covers within the IP actually makes up the network address as long as it's in the same octet as your subnet mask. So we know the subnet mask was manipulating the third octet because that's where it ended, right? It was /21. So it filled up to here, but it left these 3 blank. So we know we're manipulating the third octet. So up to this point, the IP address was manipulating these 3 to make 229. We manipulate these 3. We also manipulated some of these to add up to 229, but since these were since the 4, 2, and 1 was past the subnet mask, we just pretend it's not even there. We just add what's in front of the subnet mask within this octet, and that will give you the network. So /21, what am I thinking here? This would have been 172 is a class B, if I'm not mistaken, right? Yeah. So a class B, the other way we can do this, a class B defaults as a /18, right? Or in other words, a 255.255.0.0, right? But we're making it a /21. So then we can just do these little formulas here. So from, I'm sorry, /16, right? Yeah, /16. So it defaults to a /16, but it is a /21. So we borrowed 5 network bits. So that's 2 to the 5th, which equals, I think I got right here. So that equals 32 is your network. And then your host bits, so if you have 21 out of 32, so if your subnet mask is 21, you take 32 minus 21, because 32 is the total amount of octets you have. So that equals 11. Right? 1, yeah, that's 11. So you're going to have 2 to the 11th, which I hope I don't have anything this big on the exam. That's 2,448. But then you have to remember to minus 2 off of it for your broadcast and your network. So that's actually going to equal 2,046 available IP addresses. So that means that it's going to go up. Oh, man. How does that work? It goes up by 32s, right? No. Doesn't it go by hosts? How would I add that? I'm going to see if this is right. I think I screwed up here. Oh! I mean, I got the correct answer. Right? Yeah, that's the answer. Make this bigger. Yes, that's the correct answer. Now, did I get a little confused and maybe screw some stuff up? Yeah, because I'm not entirely sure how I would... So how would I go about... With that many hosts, right? How would I go about adding that? Would I have to divide that by 255? Is that... So I'd have 8. So that means it would go up like... No, I don't know. I done confused myself. But this is why we do it, right? So I'm going to have to work on that more. But yeah, so we went over some different routing protocols. Again, there's 2 when you look at it from the top down. There's interior and exterior. Exterior, there's only the one choice. There's the border gateway protocol. Interior, you have 2 subcategories. You have the distance vectoring and the link state routing. Within distance vectoring, you have RIP and EIGRP. RIP is outdated, somewhat smaller, limits you to a default of 15 hops. It uses hops as your metric. Your enhanced interior gateway routing protocol is a Cisco protocol. So if you don't have all Cisco devices or devices that you can use that Cisco protocol, you are Not going to want to use this one. However, it is technically a distance, but it does have to do more with the bandwidth available on the line, so it is a little confusing. Then you have link state, which is, of course, open shortest path first, which is the most common, which is what you're more likely to see than any of the other options here. And that is specifically on link state. So the faster, the more bandwidth allocated, the faster the line, the lower the number, the more likely it's going to choose that pathway. IS, intermediate systems, defaults all values to the same and then uses hops. So it's essentially just like RIP, only you can manually change those default values to make it much more loaded the way you want it to make those pathways to make those routes go to the paths you would like them to go to. So it's a little less intense than making the whole thing static. It's a little bit better than just using RIP, but it still has its drawbacks. So overall, it seems like OSPF is the optimal choice, but again, it's going to depend what you're using your network for. And then there's also like how this information was shared, right? Yeah, so distance routing protocols, these two, so here's a big difference, and this is something I didn't keep in mind. These two, RIP and EIGRP, they don't advertise the entire network, right? They only advertise what they have access to, and then they give you a description of how fast it would take for them to do that. So you're kind of, again, you're routing by rumor on RIP and EIGRP. Whereas link state, the OSPF and the ISIS, let's undo that, they advertise everything they know to the next router. That router takes all that plus everything it knows and advertises that to the next router. So with link state, your network, your routers have a much deeper understanding of the topology. They know the topology of your network. They have access to all of it. So that means they can make better routing decisions. If links go down, they can choose the best path based on all the information they have. Whereas routing by rumor, if something goes down, it might choose like the next 3 or 4 options on its routing protocol may all run into the same issue because they were all going through that same area of the network. But because they don't have a full understanding of the network, they just keep sending it down, and they're just like, oh, this one doesn't work, let's go to the next one. Oh, this one also doesn't work. And it just never makes that jump because these protocols only do what they're told to do, right? They're not cognitive brains of their own. So these are the things we have to keep in mind when we're choosing what routing protocol we're going to use. And of course, you only use one routing protocol within a network. That's like, I guess sometimes you can use multiple routing protocols, but there's no guarantee that they're going to be able to talk to each other. You're just going to cause a lot of problems. The only times you're going to see that is like when there's a specific need for it and everyone's really thought it out and it's like that's its own thing. And the other time you're going to see it is like when a business buys another business and then they have to integrate the two business like networks into one. That, no, man, you might see some different routing you might see a lot of problems happen when that shift comes. But that's going to be that's a working opportunity right there. That's job security. So I hope this was informative to anyone who decides to take a gander. I think I'm getting along pretty well. I did run into some rather confusing stuff today. Again, I don't want to be too negative on Neil Anderson. You know, for the money you're paying for those courses on Udemy, I think they do a pretty good job. That being said, if there is a topic or a section within one of those courses that for whatever reason seems to be confusing you more than informing you, use some of those other resources I talked about. A lot of those YouTube professors, they have their own courses. Like, it's on the same level, if not higher level, than what you're going to get in Udemy because they have their own courses as well. They just choose to put it out for free. There's also the Reddit, the CCNA subreddit, and there's all kinds of resources out there. If you just use your Google foo on those subjects. And it's more than likely it's going to be necessary. No one instructor is going to nail all these aspects, especially for someone who is new to the networking side of things, who hasn't worked in it. Like I'm working on not a lot of information, not a lot of like work experience and stuff like that. So that's something to keep in mind. Overall, I'm happy. I ran into some problems, but it probably just made me learn stuff better. I mean, it took longer, but it forced me to like really think about it. So that's probably a good thing overall. But with that, it's a good stream. You may have noticed it moved a couple hours later into the day. That's just to give me some more time to get everything ready. That's going to be the new common from now on. I'm going to be coming on at 6. I am going to try to stream over the weekends as well. Saturday at least. Sunday I may continue to use that to work on some other projects. But you should see me Monday through Saturday for sure, 6 p.m. And I will be back tomorrow to talk about VLANs and some routing protocols more in depth, and probably do some more subnetting practice. But I appreciate everyone who does check this out. Any people looking to hire me or just checking stuff out on the CCNA front or want to know more about these instructors, if you have any questions or anything like that, I do have a YouTube channel. It's under the same name, or Twitch channel, wherever you feel free. Wherever you want to talk to me or leave a comment, please do. I'd love the feedback. And all right, everyone have a good Monday. Take it easy.